Mixing text and numbers often turns into messy code. We'll set up a clean pattern so your preprocessing stays readable and safe. You know the pain. One column needs scaling. Another needs text turned into vectors. And suddenly, your notebook looks like spaghetti. By the end, you will see a simple pipeline that keeps these steps separate, repeatable, and leakage-free. I'm Professor Pi, teaching AI foundations with simple Python. Real teams face this every day. You collect user ages and incomes, and also collect short reviews. Those are very different signals. A numeric scaler must not touch text, and a text vectorizer must not pretend to know the whole dataset before the model runs. ColumnTransformer solves that by routing each column to the right tool. It is not a model. It is a way to keep preprocessing tidy and correct inside a training pipeline. Think of ColumnTransformer like kitchen stations. One station chops numbers, and another churns text into features. Each station runs independently. At the end, you played a single feature set for the model. Success looks like clear code, no manual feature joining, and no accidental leakage from test data into the preprocessing. We will build a tiny toy dataset with ages, incomes, and short product reviews. Then, we will wire a ColumnTransformer that applies numeric scaling to the numbers and TF IDF to the text. We will show cross-validation to prevent leakage, try a small tweak with bigrams, and finish with a proper train test split to get a safe test score. Now we will create the mixed dataset. This snippet builds a tiny mixed dataset with numeric and text features. The list's ages and incomes hold numeric values, and the list reviews hold short product comments that correlate with the target Y. A pandas data frame named X organizes columns by name, so later transformers can select by column. The labels Y are binary, matching the order of the rows in X. We keep values small and interpretable to make downstream transformations and metrics easy to verify. The printed row count confirms the data shape we will reuse. Next, we will wire preprocessing for numbers and text. This snippet uses scikit-learn ColumnTransformer to combine numeric scaling and text TF IDF. The object pre applies StandardScaler to the age and income columns, and TfidfVectorizer to the review text. Calling FitTransform on X learns scaling stats and a vocabulary from the current data, outputting a single feature matrix. The variable n stores the total number of engineered features across both branches. This shows how to declaratively wire mixed preprocessing in one object. Now we will evaluate the whole pipeline with proper folds. This snippet evaluates a scikit-learn pipeline with cross-validation to avoid leakage. The pipeline chains the ColumnTransformer pre with a LogisticRegression classifier, so each fold fits text and scaling only on its training split. K-fold with shuffle and a fixed random state ensures repeatable splits. Cross-val score runs the full fit and score loop per fold, returning scores in S. The mean accuracy summarizes how well the preprocessing plus model generalize without peaking at held-out data. A perfect score here reflects clean separation in our toy text. Next, we will try a small text tweak to capture phrases. This snippet expands the text features by enabling bigrams in scikit-learn's TfidfVectorizer. The new ColumnTransformer Pre2 keeps numeric scaling, but sets n-gram range to include unigrams and bigrams from the review column. After FitTransform, N2 reports the larger feature space produced by adding phrases like great fit and bad price. Increasing n-gram range can capture short phrases that carry meaning, but also increases memory and training time. Decreasing it simplifies the model and speeds things up. The printed feature count shows the tangible effect of this tweak. Now, we will train a final pipeline and test it on a holdout split. This snippet trains a scikit-learn pipeline with the tuned ColumnTransformer and evaluates on a holdout split. Train test split with stratify preserves class balance, and random state ensures a repeatable split. The pipeline pipe best fits preprocessing and the LogisticRegression on XTR and YTR, then scores on untouched XTE and YTE. Because preprocessing lives inside the pipeline, the test data never informs scaling or the TF IDF vocabulary. The printed test accuracy is a small, clean baseline that's safe to ship. This toy maps directly to a real project. Replace the small lists with your production table. Keep ColumnTransformer in the pipeline, and you will avoid leaking vocabulary or scale parameters into your test set. When you add more data, monitor vocabulary size and training time as TF IDF features grow. Recap. ColumnTransformer lets you apply different preprocessing to different columns and then join the results for a single model. Use this when you have mixed types like numeric features and free text and want tidy, repeatable preprocessing. Caveat: text vectorizers can explode feature count, so watch memory and overfitting. Next step: tune TF IDF n-grams and the logistic regularization to trade off phrase sensitivity against model size and variance. Start by expanding n-gram range and monitoring validation accuracy and feature count. If AI Foundations in Python help, subscribe and watch the AI Foundations videos.